So we're doing 16 today, and we're going to do some fancy work with distributive property and just simplify just crazy stuff. So here we go, Hannah. Let's try to make our lives not too difficult. We should be able to do that, but as we know, life is difficult. Here we go. So we have, oh, we don't. Now we have a times x, negative a minus x. And we have a equals 2 and x equals negative 1. All right, so our goal here is to distribute everything to its correct place. Now what I like to do when I rewrite these problems, to keep everything in order, I like to change each and every letter to, I want to change this, each and every letter to a parentheses. Which means I have to change all my other symbols. So I just like to change all my letters. It just makes my life a lot easier by doing that. All right, then for all the spots where A was, I'm going to write a 2. And where all the spots where X is, I'm going to write a negative 1. That way I can see what's going on. So I can handle each little part separately. So on the outside, I'm going to end up with negative 2. On the inside, I'm going to end up with negative 2. And then I need to take care of these brackets here. 2 minus minus 1 is 3. That's 2 plus 1, right? Then I can do the distributive property here. Negative 2 times 3 is negative 6. Then I can do the distributive property to my negative 6. Negative 2 times negative 6 is positive 12. Does that make sense, Hannah?
Yeah.
So the goal, the trick to make sure I'm doing these right is to make sure I am putting everything in its correct place. So a couple more practices. And if you want to come up and practice one, you're more than welcome to. If you don't, no pressure. Okay, so you tell me now, what should I do to keep myself organized?
Have like the little parentheses and then you'll fill it in kind of.
Yep, so every single letter gets a parentheses. All my symbols of inclusion go up a step. So,
Oh, that's what it is.
yeah, I'm just changing them because these parentheses are going to switch over to these. I'm changing all my symbols of inclusion as well to keep my order. Okay, so B is negative 2. And another good reason to do the parentheses is when you start having all these negative signs, it keeps everything separated. And as the offspring say, you've got to keep them separated. Oh yeah. All right, cool. All right, so let's do all our fancy work inside the parentheses. I don't want to rewrite this constantly. So let's take a look at this one. Negative 2 minus 0. Yep. 0 minus minus 2.
2.
Positive 2. Yep. Now I have this over here I have to take care of. Negative 2 is positive 2. And I have to distribute that to here before I can subtract this. Okay?
Then that would be 0.
No, it's 2 times negative 2.
Oh, so negative 4.
So it's negative 4 minus 2.
Negative 6.
So negative 6. This is all done. Everything in those braces are done. Negative 2 is?
2. So it'd be 2 minus 6.
Okay, this is multiplication because it's on the outside.
Oh, you gotta bring it in.
So I got to distribute it. So this is positive 2 times negative 6.
Which is negative 12.
Negative 12. All right, so yeah, when you're doing distributive property, we need to make sure that we are keeping tabs on everything we are doing. All right, so here's another one. 5y times 2z times 4x y. X equals 3, y equals -1, and z equals 1/2. Okay, so I'm going to change these parentheses into the braces, like that. 5 times parentheses, 2 times parentheses, 4 times parentheses, parentheses. Okay, got everything changed. Okay, so x is 3, so that's 3. Y is -1, so -1, -1. Z is 1/2. Okay? Cool? Okay, so this is straight up multiplication. So I'm going to take each section first. 5 times -1 is -5. 2 times 1/2 is
2 over 4.
2 over 2, which is 1,
Oh.
right? 4 times 3 times -1,
-12.
-12. Now multiply it all again. -5 times 1 times -12 makes positive 60. Okay? Let's do a division one so we can see all the examples that you're going to face today. R equals -1, S equals -3, T equals -2. Okay, so again, now when we have division, we do the top first, then we do the bottom second, and then we divide. So -1, -3, -3, -2. So the top, 4 times -1 times -3 would make positive 12. On the bottom, 6 times -3 times -2 would make
So that would be positive 96?
36.
36.
18 times 2.
Oh.
Okay, then I would reduce that and I would get 1/3. Okay, now what if you were doing a problem that looks like this? -b times a minus 3 plus a. I told you a equals 2, b equals -1, and I said justify each step.
Oh. You would have to fill in the letter areas with the numbers.
I would say, now your book's not telling you to do this, but I'm telling you to do this for your sake. I don't always agree with everything the book says. So your very first step would be to insert the variables. All right, to insert the variables, and this is all I'm doing. So my very first step, when you are told to justify, oh, I didn't need to write that one in parentheses. When you're told to justify, my first step would be insert variables, or insert numbers. My second step, now you can do this two different ways. Your second step could be to solve the parentheses or to distribute, doesn't matter either way. If you solve parentheses first, I'll do this both ways, you would do this. I'm going to rewrite this problem twice so at least you can see it. I'm going to get it squished here. Okay, I'm just trying to show that there's two different ways to do it. So the first one, solve parentheses. So we do -1 is +1. 2 minus 3 is -1 plus 2. So I solve my parentheses. 3 distribute. So we're going to do 1 times negative 1. So it's negative 1 plus 2. Answer would be 1, right? And then I would, for my fourth step, I would add. I could do it the other way around. If I distributed first, Hannah, I would take my, this would be positive 1. I take my positive 1 to here and here. So that would give me 2 minus 3. I still get negative 1 plus 2, which is still going to be 1. Okay? Either way I'm distributing, it's just when am I going to distribute. You can kind of pick and choose that. I like to solve all the parentheses stuff because it means I have less errors when I distribute. Sometimes I feel like when I distribute before I do that, I have more problems. But it's kind of up to you at that point. So this is just saying what you did to get to the answer. Inserted the number, solved the parentheses, distributed, then I added. That's how I solved the problem. See, when you have to justify, you're just explaining what you did. Like if you get caught doing something wrong, what do most people try to do, kids and adults? Try to justify their actions.
Oh, yeah.
Right?
Yeah.
Sometimes they have good reason to do what they did. Sometimes they don't. But most people try to justify their actions. And most of the time you don't have a good reason for doing something wrong. Almost all the time. Alright. Alright, so a final problem. A savings account grows according to the formula P equals 1.04. So here's your savings account. Hannah's savings account. Make that too small. Where
PY or
PY. Big P, little y is the principal balance at the end of Y years. Okay, so this is how much money you have after so many years of it being in your savings account. The Y stands for years. P is how much money it was. And P, this one, P, Y minus 1, is the principal balance after Y minus 1 years. After 6 years, there's a principal balance of $1,600. How much is the principal balance after 8 years? Okay?
So why is there a B in there?
It's not. I wrote a little, I'll erase it. I wrote a little p, and I should have written a big P. That's my fault. All right? So this doesn't have to be there. All right. So if the principal balance in after 6 years was $1,600, what is the principal balance after 8 years? So that's going to be 1.04 times, what do you think?
1,600
Times 1,600
minus 1?
minus 1.
And then would that...
Actually, it's going to be 1,600 times how many more years? We said 8 years, right?
8 years, so it would be minus 8?
Times 2 minus 1.
Oh, so it'd be 1,600 or 16.
I'm going to pause this for a second. So I want to show you. Okay.